Uh, Hello, my name is Benoît Pansard. I've been working at Sigfox for more than 4 years in charge of standardization. Today I'm going to present the radio specification for Sigfox connected devices. In this presentation you will learn how the document is structured, where to find format, functions and procedures definition for the Sigfox radio protocol. Throughout my presentation, you will have hints on the uplink and downlink protocol stack, but this is not the main scope of this talk, since many other presentations are available on this topic. So let's move to the next slide, which is just a quick reminder of the Sigfox solution. In Sigfox, messages are sent by devices and collected by radio hubs deployed by Sigfox. Radio hubs transmit received messages to the Sigfox cloud, where authentication, deduplication, and or other features are performed before they are transmitted to external servers where the client application is hosted. In this presentation, we are going to talk about the device radio specification, which are focused on the device radio interface. Radio hubs and Sigfox Cloud are not detailed. Therefore, the present document will only speak about Sigfox network in general. As usual, uplink transmission is for a device to the network, and downlink is from the network to the device. Okay, so having said that, let's move to the document itself. Section 2 is mainly focused for radio engineers. In this section, you will find everything you need to start the design of your radio frontend for your connected object. This section starts with the unlicensed frequency band, as you can see here. These bands are used by Sigfox in each region where the Sigfox solution is available. Then you will have all details about power transmissions, modulation scheme, modulation rate, transmission mask, burst shaping, and many other radio stuff. In downlink, the key receiver parameters are detailed and their recommended target values are given to get a good quality of service in downlink. If you are a radio design engineer, this chapter is definitely for you. If you are more interested in embedded software, I can imagine that the next section 3 and 4 are much more of interest than dBs, megahertz, or part per million. So let's move to the next section. Section 3 gives any details about uplink protocol stack, that is, on the communication between the device and the Sigfox network. It starts with message content description, and then you have details about headers field such as length indicator, a relay flag, repetition flag, message count, which is incremented after each transmission, and then ID field. Then the protocol implements an authentication and integrity check with an AES 128 algorithm in mode CBC. The next step is a CRC for error detection, a convolution code in case of multiple frame transmission, and last but not least, preamble and frame type insertion that helps the receiver to detect messages. The last step in the protocol stack is modulation, but it has been addressed in section 2 already. The last part of section 3 is about procedures for uplink communication. The first procedure is single or multiple frame transmission, and the second procedure details frequency selection mechanisms and time delays between successive radio bursts. That's it for the uplink communication protocol. Everything is detailed in section 3. Now let's move to section 4. Section 4 is about downlink communication, that is to say from Sigfox network to devices. I guess you already know that downlink communication is triggered by uplink transmission in a Sigfox system. That's why the downlink protocol stack is a bit simpler than the uplink protocol stack. This is because in Sigfox radio interface, the network is under the control of devices and not the other way around, as in many other communication systems you may know. So, in the device radio specification, we have chosen to describe the downlink protocol stack in the same way as in the uplink description. That is to say, starting from the message content down to a radio burst over the air. So, section 4 starts describing the message content, then authentication field and how it is evaluated with the device ID from the uplink message, message counter, and device secret key. Then we have a CRC for error detection, a BCH code for error correction, and a whitening function. Radio frame is then concatenated with preamble and frame type as in uplink before going to the modulator and power amplifier. So it's quite straightforward if you have understood the uplink protocol stack. The downlink protocol stack is quite equivalent. The second part of section 4 deals with the bidirectional procedure. Or, in other words, how a device sends an uplink message to trigger a downlink message transmission in the Sigfox network. Bidirectional procedure implements a set of time intervals that are extensively illustrated in a different section, which is Annex 6. Section 5 is much more small than the three previous ones, because it's about applicative and control level. Applicative messages are messages from a user application. Their format is free, so the only constraint is message length that goes from 0 bit up to 12 bytes. Control messages are mainly to carry status of devices such as battery power level, device temperature, or receive signal strength in case of bidirectional procedure. Format of control messages are detailed in section 6. Section 7 is just about the table summarizes message types, message lengths, and how they may be optimally put in radio frames that have optional lengths. I don't want to finish my talk without speaking about the last section 8, which is about usual stuff in specification documents such as definition, acronyms, symbol list, and drawing convention. Okay, I think that's it for today. I hope you have enjoyed my presentation and you are eager to start designing your device. Thank you for your interest in Sigfox device radio specification. Bye-bye.